Alright, so here we are, way back when, trying to invent the internet, and we're getting aggravated because we're already running into a bunch of problems. First of all, we need to assign an identification number to each device, but A, we have a limited amount of memory. I mean, back then, if you want to buy a new hard drive, it's probably going to take up like 3 rooms in your house. So memory really, it wasn't cheap back then like it is today. So we can't just like add more bits to this IP address because we're limited in that aspect, and also we're scratching our head because we don't know how big the networks that are going to make up the internet are going to be. Maybe this one has 100 computers. Maybe it's just like a college. Maybe some other country is making a network and they have tens and thousands of computers. What the heck are we supposed to do? Now, we already learned in the last video that we're going to need to break this up eventually so that one part is for the network and one part is used to identify the host. And we can't just stick this anywhere because, again, like I said, networks are different sizes. So some brilliant guy walks in and he's like, you know what? What if you added some information that said how big your network was going to be? But then everyone yelled at him because we're like, hey, dude, we told you we only have 32 bits that can transfer across the network. We can't just add like 100 some special code to say how big your network is. So we're like, alright dude, get out of here, we're done with you, you're fired. So he's like, whoa, hold on, let me get this straight. So you only want to use 32 bits for the IP address, and you also don't want to waste any IPs, so you don't want to put a hard break anywhere, and also you want the size of the networks to be different. For example, if someone has a small network, you want someone else to have a big network, and everything can work out fine. You want it to be flexible. You know what? I have a solution for you guys, and this is what he came up with. Ladies and gentlemen, welcome to Subnetting. Now, what that guy said is, you know what? Keep your 32-bit IP address. I know that computers aren't really that advanced right now. They can't handle numbers longer than 32 bits. So here's what we're going to do. Whenever two computers try to communicate with each other, we're going to send them the IP address, just like before, right like this. We're also going to send them an additional 32-bit number. This is called the subnet mask. Now, whenever we see a 1, this represents that this portion of the IP address is for the network. Whenever we have a 0, that portion of the IP address is for the host. So all subnet masks that you see, they're always a string of 1s followed by a string of 0s. That's all they are. Now this means, in this example, that the first 20 bits of the IP address is designated as the network address. The last 12 right here, these last 12 can be used to identify the host, the individual computers. Now, another guy was like, alright, that sounds dumb. We already had that problem. What happens when, we have a smaller network and it doesn't have that many computers? Well, all we have to do is take this subnet mask and change it to 1111, and now we can designate 24 bits to the network identifier and only 8 bits to identify the host. So we can have networks that are smaller or bigger, and we never exceed that 32-bit number. Now, if you're wondering, alright, why is this useful? Why do we even care that the system is designed this way? Well, let's think about it. Whenever we design a system in this way, it can move a lot faster. It's a lot more efficient. Now, let's think about just sending a letter to your friend who lives in Texas or whatever for just a second. Whenever we send them a letter and we pass it through the mail system, no single person in that mail system knows where everyone in America lives. You have one person that handles it first and they make sure it gets to the right state. Then it goes to another person and they make sure it gets to the right county. And it goes to another person and they make sure it gets to the right street. So no one central location has all this information. Instead, we have multiple different devices that can fastly and efficiently transfer that data or that letter correctly. Now I'll show you guys this example. So for the network portion of it, all it does is it says, okay, this is where I'm sending it. It's very simple and it breaks it down. And this is also why we can have 6,000 Bob Williams in America and we don't have any problems, because yes, we have a bunch of Bob Williamses, but only one of them lives at like 864 Maple Drive in Texas. So it doesn't become a problem. Now, for the network portion of this, whenever the network is trying to send data, this is what it sees. Okay, I'm just going to make sure that this data gets to the correct network. That's all I'm going to do. What happens after that? Not my problem. It's kind of like whenever the mail person delivers the letter to someone's house. Yeah, who's this letter for? Is it for little Mary, my little sister? Is it for my mom, my dad? Is it for me? Hey, I'm just giving it to the house. After that, you guys decide, whose mail's whose. Not my problem. That's pretty much how this system works as well. The network is just responsible for taking that data, sending it to the correct network. It doesn't really care about the individual computers, and then once it gets to that network, it says, okay, let's rip out this portion of the IP address. I'm going to look through all of my individual hosts in my network, the individual computers, and I'm going to take the data and send it to the right one. So that, ladies and gentlemen, is the basics of how the internet works, how you can send and receive data and it always goes to the right computer, and how you can post your selfies and send pictures of whatever you want to your girlfriend. So yeah, hope you understood it. If you have any questions, ask me in my forum, and I'll see you guys next video.